All right, guys, let's do some solving of rational functions. And something is rational if it can be written as a fraction. So when we have rational equations, it's equations that have fractions in them. Let's say 1/9 plus 1 over x. Oops, equals 1 over x. Sorry, guys. Sorry. Equals 1 over x. Let's see, what do I want to do? Let's add this side together first. So if I can add 1/6 and 1/9, then I can just cross multiply to solve for x. So I'm going to add 6 and 9 have a common multiple. They can both go into 36. 6 can go into 36 6 times. 9 can go into 36 4 times. So 4/9 is 4/36 is the same as 1/9 is equal to 1 over x. 6 and 4 is 10 over 36 is equal to 1 over x. So if I cross multiply, 10 times x is 10x is equal to 36. Divide both sides by 10, x should be equal to 3.6. I'm just trying to remember if 1, 2, 3, 4, 36. Yep, that's correct. My multiplication by 9s. Okay, what's next? Okay, so this next part is cool. We have 12 over x squared minus 9. But like right away, you guys, I'm noticing something. I'm noticing that x squared minus 9 is a difference of squares. I know that that's the same as x minus 3 times x plus 3. And I'm going to change my denominator to reflect that. Because if you keep reading, you see that over here I have 8 over x plus 3. And then minus 2 over x minus 3. Okay. And the reason I'm looking at this is because there is a common multiple for every single term here. And that common multiple is x minus 3 times x plus 3 times x plus 3. And for the first one, and I'm going to multiply this entire thing by each term in my equation, okay? And the first one, this entire denominator cancels out with this, and all I have is 12 left over. So now 12 is equal to, okay? And here, this part, the x plus 3 part of the denominator cancels with this x plus 3, okay? And what I have left is 8 times x minus 3 minus, over here, my x minus 3 cancels out with this, and what I'm left over with is 2 times x plus 3. All right, and now it looks like it's just going to be a linear equation. I just need to combine like terms, so I'm going to distribute 8x minus 24 minus 2x minus 6. 12 is equal to 8x minus 6x minus 30. Add 30 to both sides. 42 equals 6x. Divide both sides by 6. X equals 7. So that was a lot easier than I thought it was going to be. And the last one of these rational functions is 3 over x minus 3 minus 6 over x minus 5 equals, now I'm going to factor, that was ugly, factor the denominator, and two numbers that add up to be add up to be -8 and multiply together to be positive 15 are going to be both -5 and -3, I think. So, oh look, so that works out perfectly, right? We're going to do the same thing as I did on the other one. I'm going to multiply the entire equation by the greatest least common multiple of everything, which is just this entire denominator there. Okay, so on this side, the whole thing cancels out, and I have x minus 9 is equal to, here, just the x minus 5 cancels out, so I have minus 6 times x minus 3, and over here the x minus 3 cancels out, so I have 3 times x minus 5, and again, we just get this kind of linear relationship here, so distributing through, negative 6x plus 18 equals x minus 9. Let's move, well, let's combine like terms first. So this is going to be negative 3x plus 3 equals x minus 9. And then I will add the 3x's to the other side and add 9, so I get 12 is equal to 4x. X is equal to 3. Cool, cool. I don't see that it's asking for domains and ranges, but when we move forward, I do not want us to forget what we need to look back at the original equation to say if x could or could not actually be a solution for that, and actually it looks like 3 wouldn't actually be part of that solution because, and I should go back and check the other one that we just did, if x was 3, that would make 2 of the denominators on the in the original equation non-existent, right? So this 3 is an answer, but it's what we call an extraneous solution, which is actually kind of a hole if we were graphing that function. Let's go back up. I just moved us back up to this other one. We had 7 as our answer, and that's just going to be a real solution for this one because it's not going to affect any of our denominators at the top. But it wasn't in anything that we actually did this time around, so I'm not too worried about it. But just so you know, if we get something that makes a 0 on a denominator, it's going to be an extraneous solution. Let's see. I think I have time in this video. Question 10 says use the discriminant, and what it means by that is when we think of the quadratic formula, it's negative b plus or minus, are you singing? The square root of b squared minus 4ac all over 2a. When we talk about the discriminant, we're talking about this piece right here, okay? And it's asking us to use that to decide on the number of solutions. So the thing is, if we have a quadratic, there are 3 things that can happen, right? We can have 2 solutions because it crosses the x-axis twice. We can have just 1 solution because I know it doesn't, I didn't make it touch here, but if it just touches and goes back up. Or like we can have no real solutions if it never touches the x-axis. And that's okay too now that we have been working with complex numbers. But that can all be figured out by just doing this part of the quadratic formula. If we have 2 real solutions, then underneath the radical, we are going to get a positive number. That's going to give us 2 real solutions. If we aren't going to have any solutions, any real solutions, that means the discriminant has a negative number, right? Because those are going to be imaginary answers. If it only hits once, that means that underneath that discriminant, we are going to have 0. That means we're only going to have 1 answer, right? Plus or minus 0 is going to be the same thing. You add 0 to something, you subtract 0 to something, you're going to get the same answer. So that means there's only going to be 1 answer. So if we look at A, it says x squared plus 4x minus 8 equals 0. Our discriminant is going to be 4 squared minus 4 times a times c is negative 32. That means we get 16 plus 32, which means we have the square root of 48. which is a positive number. So we're going to have two real solutions for this problem. Then it says to finish using the quadratic formula or completing the square. Let's do completing the square since you guys probably need more practice at that. All right, so we're going to have x squared plus 4x plus, and we're going to move the 8 over to the other side already. Half of 4 is 2, 2 squared is 4. Okay, if we factor that, we get x plus 2 squared equals 8 plus 4, because we add what we do to one side, we have to do to the other. So it's actually going to be, instead of 8, that's going to be 12. I'm doing my mental math really quick, so I'm just waiting to get a text from one of you guys saying it's wrong. 12, and then we take the square root of both sides. 4 times 3, I think 2 root 3. And where that came from was the square root of 12 is the same as the square root of 4 times 3. The square root of 4 is 2, so I can take that 2 out. So 2 root 3. And then minus 2 from both sides. So x sub 1 is equal to positive 2 root 3 minus 2. And x sub 2 is going to be negative 2 root 3 plus 2. Nope. God, you guys, my mind is going. It's still minus 2, only the plus or minus in the front changes. Okay? All right, and the next one, the discriminant is, let's see, we have x squared plus 6x plus 10. So the discriminant is going to be b squared minus 4 times a times c is 40. So check it. The square root of, we're going to get the square root of a negative number, negative 4. Is that right? 36 minus 40, I think so, negative 4. So we're not going to have any real solutions to this. So what are our solutions going to be? Why don't we use the actual quadratic formula? I already did the inside of I did the determinant there, so we're going to have negative b would be negative 6 plus or minus the square root of 4 all over 2a is just going to be 2. So how do we simplify this? All right, it's going to be equal to, and let me just take this outside. The square root of negative 4 is going to be the same as the square root of 4 times negative 1. The square root of 4 is 2. The square root of negative 1 is I. Okay, so the square root of negative 4 is 2i. So then what does that look like? That's going to make it a lot easier to simplify, 2i. If everything is divisible by the same number, I can simplify it even more, which it looks like it is. So this is going to be equal to negative 3 plus or minus I all over 2. So x sub 1 is going to be negative 3 over 2 plus I over 2. And I'm writing it as a complex number, okay, which means we have to separate it out. And x sub 2 is equal to negative 3 over 2 minus I over 2. I think I would accept this entire answer over here as your answer. It doesn't tell me one way or the other. This, I just wanted to remind you, since we just did this, this is how you would write an actual complex number, because you have to have the real part and the imaginary part in order to graph it. Okay, that's why we call that a complex number. All right. where are we at? Oh, we're done with 10, so I think I'm going to stop this video, start the next one.